Okay, so if you're paying attention to the order that I've been doing these things, you're going to notice that this one's out of order from what we've been doing. I kind of wanted to skip the next thing I originally had planned because it seems to make a little bit more sense kind of off on its own, but it is still related. So I'm calling these shadow problems because that's basically what they deal with. So if you consider like when you go outside, it's a bright sunny day, your shadow's length is directly related to how tall you are. And depending on the angle of the sun, that shadow length can change and whatnot. But the cool thing is, every object at that same time of day has a shadow that is proportional to your shadow. Okay, now, big picture, what I mean by that is these things are related. So, if I know I'm going to round down a little bit, but I'm 6'3", but let's just say I'm 6 foot tall, right? My shadow here, the length of this shadow is going to be in the same proportion as this 20-foot tall tree here. So I can set up a proportion using, and kind of forget this over here, I can set up a proportion kind of using these two vague pictures to figure out how long my shadow is. Okay. The nice thing about these is every single setup, every picture wise, is pretty much the same. You're looking at a right triangle, and you're either going to be given the height of the triangle or the length of the triangle, and you're setting up a proportion. The actual hypotenuse, the diagonal lengths of these, we're not too concerned about. Okay, so this scenario that I've got set up here, if I wanted to know how tall or how long my shadow was compared to the 25-foot shadow of the tree, I would compare my height to the height of the tree. Okay, these are really straightforward to solve. There's nothing too complicated as far as like having to distribute or anything like that. So you would cross multiply this and get your answer, 7.5 feet. Okay. The units aren't really necessary on this. It's kind of like what we've done in the past. If your pictures are given in, feet, inches, miles, your answer is going to be in the same unit. So it's kind of inconsequential. So these are word problems, though, so you're going to have to read a little bit. Basically, you need to be able to tell the difference of a vertical distance and a horizontal distance. And shadows are always on the ground. So I do draw pictures for these. I've got a tree. They don't have to be super detailed pictures. A tree 24 feet tall casts a 12-foot shadow. Brad is 6 feet tall. How long is Brad's shadow? Now, some of these you might be able to kind of spot the ratio and see what's going on here. You don't have to by any means, but what I'm looking at here, if you kind of know what you're doing, you can see that this is the shadow's a length of 3. But I'm going to go back to the proportions here. I'm looking for Brad's shadow. I'm going to compare that to the tree's shadow. That is equal to Brad's height compared to the tree's height. So cross multiply. And then when you divide out 24, Brad's shadow is 3 feet, just like I said. Okay. There's more than one way to do these. Please don't think that I'm telling you there's only one way to do these, but I'm going with like the most direct route tied exactly into what we've been doing the last few days. All right, a 40-foot flagpole casts a 25-foot shadow. Find the shadow. Oh, my pictures are backwards. Find the shadow cast by a 200-foot tall building. Okay. Again, I probably should have read the whole problem before I started drawing my pictures, but so my building is way taller than the flagpole. The shadow of the building compared to the shadow of the flagpole is equal to the height of the building compared to the height of the flagpole. Okay, cross multiply. And then when I divide out my 40, shadow of the building is 125 feet. Okay. Don't overcomplicate these, okay? These don't need to be big, complicated problems. Just pay attention to, if you're looking for the shadow, it's going to be on the ground. If you're looking for a height, it's going to be up. And pay attention to your two separate pictures.